Okay, we might make a start. We've got a lot to cover tonight, so we're going to dive straight in. I would like to welcome everyone here tonight and acknowledge the traditional owners of the lands on which we all meet and pay respect to their elders past, present and emerging. For those who weren't here last week, my name is Catherine. I am the Business Development Officer at Partners in Ag. We are a not-for-profit organisation that provides training workshops for farmers and rural communities across Victoria and Tasmania, and we welcome our interstate friends as well tonight. This webinar series has been brought to you by the Wimmera Catchment Management Authority with funding from the Australian Government's National Land Care Program. So thank you very much to those organisations. Some housekeeping for tonight. If you could all please stay on mute while we go through the presentation tonight and ask your questions in the chat function. Both David and I will be monitoring that over the course of the evening. So we will try and get to as many questions as we can throughout, and there'll be time at the end to ask questions as well. So I would like to introduce David. David is an agroecologist and has over 20 years experience in rural landscapes, farming and food systems. He develops and delivers many extension projects for soil, land and food across Australia. I'd like to welcome you, David, and hand over to you for the presentation.
Thanks very much, Catherine, and welcome back, everyone. I think there's one or two that are not muted, Catherine. Yeah, might just have to check that out. I think Joshua down the bottom might not have his mic off, but yeah, thanks everyone for coming in and being part of the program. We'll kick straight into session 2, so I'll just share my screen, everyone. Bear with me a minute. All right, can you guys see that screen there? All good, thanks Catherine. Okay, well, welcome back everyone to session 2 of the Reboot My Soil Health webinar series. Hopefully you got something out of session 1 last week, and we're just going to keep rolling on with the topics that we outlined in the beginning, and we're going to jump into using soil tests a little bit more tonight as well. If you do have a question, please put it into chat, and we'll keep an eye on the chats and make sure we get to the question as best we can. So let's jump straight in, if I can get my screen to work. There we go. And we're on this journey of rebooting our soil health, and we were set a challenge by P.A. Yeomans in the 1940s and 50s, where he made the statement that agriculture itself can be a soil making process. So this is really our challenge. Can we do agriculture, make money, and still build and maintain the soil asset at the same time? And I think the answer is yes. It's not always really easy necessarily, but it can be done, and it can lead to long-term benefits for your farm business. The course, just a quick refresher, the course is really about managing soil health or rebooting your soil health on your property. And the key skills that we're practicing are using soil tests, benchmarking soils, which I'll go into a little bit more tonight, and I'll also demystify soil tests tonight. They're the 2 big things we'll do. And then we don't do a lot of field assessment of soils because it's an online course. We've already identified soil types in session 1, and I gave you some thinking activity to do around, is your enterprise and your yield expectations matching your soil types? Because if it's not, then you may need to consider adapting so that you're more profitable. And thirdly, the final skill there is obviously managing soil health, which is a core focus of this webinar series. So that first skill was identifying your soil types, and people usually have more than one soil type on their property, and that's texture, the size of the soil's colloid, which we measure with CEC, colour, and mineral composition. What's the overall inherent fertility of a soil? And the second one then was making sure you're matching your enterprise and your production goals to your soil types, because otherwise you're often putting out more inputs than are possibly economic to sort of push that productivity beyond the capacity of the soil asset. So it's really about adapting your enterprise to your soil types as much as to your climate and to other factors. There's a few resources. There's the soil action plan, which we've sent out, as well as a guide to soil health and some rash videos, which are available on YouTube. Okay, so the course again is all about soil health, and tonight we're getting into using soil tests. So we're going to look at soil tests, the what and why of them, and we're going to explore the different labs and the different test options from the labs, the different approaches that people take to using a soil test. So the same soil test can be read differently by different agronomists, for example, and that can profoundly impact what you prioritize in terms of soil health management. Someone might think you need to focus on X, and someone else might think you need to focus on Y or B or C on the same soil test. And that can mean spending $10,000 or $50,000 or no dollars and getting a result, or not getting a result, or getting a little bit of a result. So that's pretty critical. And we're going to pull apart a soil test, and I'm going to show you the 5 elements on any good soil test. And once you understand those 5 elements, soil tests become a lot easier to use. I'm not saying they're always really fully easy, but they're definitely a lot more easy when you understand those 5 elements. We're going to start to practice soil benchmarking using carbon, the big C, and then we'll be just taking you through soil health. Now, I am covering a lot of ground tonight, so I will scoot through a little bit quicker than I usually do, and it's only because we've kind of made this a 4-part series, and so tonight's the night that I'll have to squeeze a little bit in more than I normally do. So I'm going to keep going, but if you have a question, put it into chat and I'll pause and we'll try and address it as we go. So let's jump into this first really important core skill, one of these core skills, the 3 core skills of soil management, and that is using soil tests like these guys are here in far north Queensland. So the first question is, what are soil tests? And the answer is really they're a tool to help you manage your soil more effectively. That's pretty much all they are. They're a tool in the toolbox to help you manage your soil more effectively. And so there's different reasons people use soil tests. And just because of time, I won't get everyone to sort of punch in their answers and spend time on that. But suffice to say that there's, in this room there, in the picture you can see there, there's a couple of Department of Agriculture researchers. There's a vegetable farmer, and then there's an agronomist all sitting around the table. And people have different reasons for using soil tests, but generally the main reason people use soil tests is to make nutrient decisions. So they usually ask themselves, how much fertilizer do I need, or what nutrients does the plant short on that I need to add to the soil? That's the most common and priority reason people use a soil test. How much fertilizer do I need? But they are also used, obviously, to address certain soil health issues or soil constraints. And in particular, people use them to look at pH, to manage the acidity in the soil, and therefore make a liming decision. Do I need to add lime? So they're probably the 2 biggest reasons people use soil tests. And for better or for worse, people often focus on the nutrients first. But I'd suggest to you that although fertility management with soil tests is really important, but there's a step before that, and that is using a soil test to manage soil health, because there's no point putting fertilizer on the soil if the roots can't take it up effectively because of soil constraints. So you kind of, what we do is prioritize soil health over fertility, although sometimes you need to manage both at the same time. So a soil test as a tool can help you with 3 key things. It can help you understand your soil's type, which we looked at last week. It can help you manage soil health, which I've just referred to. And yes, it can help you make your nutrient decisions, which is really managing soil fertility. And this is a cane farmer in far north Queensland who's showing some other farmers and graziers the particular challenges of that very peaty soil north of Cairns. So wherever you farm and graze, soil is pretty much the second most important asset in your farm business, the people being the most important, obviously. And most soils have issues. The only farmers and graziers I've met that don't have soil issues are the ones that are now retired on the coast. But everyone else has at least some challenge, or most people have a challenge with their soil to improve it or to overcome some weak link in it or whatever. So yeah, soils are an important asset. It's easy to burn money on your soil and not necessarily get the greatest economic return, or it's also easy to lose potential income if your soil is not performing well, because if you have soil constraints, then you are losing potential yield because the plants won't be growing to their optimum. So that's what we call that's the double whammy of soil health, of soil constraints. Is one, you're usually spending money to fix the problem, and two, if you're not fixing the problem, you're losing potential income. So it can have a double effect on the bottom line. So basically, soil tests help you make decisions so you can take action. They're not perfect agronomic soil tests. They don't tell you everything. They're not 100% accurate, but they're very useful tools when they're used carefully in a holistic way. So, and they are, realistically, they are 20th century technologies. A lot of the soil chemistry tests that we have are mid to sort of middle late 20th century tests. So they're, you know, they're not kind of the latest cutting edge thing, but they are very useful methods to help us make management decisions. So they're a tool to help you manage the soil asset well and target your inputs as well. So let's jump in a little bit and look at some of the aspects of labs and tests. So the reality is that there are different labs and different soil tests that the different labs offer. There's a bit of a selection out there. So here's some cane farmers in the Burdekin of North Queensland. And the unique thing about the cane industry is even though they can use different tests, different labs, they can choose a different lab for their soil tests, but they actually have regulations now about for some of their soil aspects, which tests they're allowed to do. So it's now prescriptive for them, which is very unique. There's no other industry where there's regulated prescriptions about which phosphorus test, for example, I'm allowed to do legally. And that's because of the barrier reef and all of the environmental risk or perceived environmental risk. And I guess there is environmental risk. How big it is, it would depends a little bit on the different areas. But yeah, so you can sort of see they have some choices, but they also have some limitations to those choices. But everyone else has a wide range of tests and labs to choose from. I've just put a few of the labs up there on the screen. We've got SWEP, Nutrient Advantage, which is owned by the big company Insotech Pivot. We've got Fosin Analytical, which is a specialised lab in Queensland. You've got AgVita, EAL, APAL, CSBP, which is a big lab in Western Australia, also operates in the East Coast now, Hortus. So I've missed a couple in Australia, and it's not intentional. It's just that I've just put a selection of them up there. There are a number of other labs as well. So there's lots of labs out there that you can choose from. And different agronomists have their favourite labs. So sometimes an agronomist likes to use one particular lab or another. And within each lab, the reality is that within each lab, depending on the size of the lab and how many different services they offer, you'll have a catalogue with a range of different test options. So, you know, this is EAL's front page or table of contents of EAL's agricultural catalogue, and soil testing starts on page 4 and goes to page 8. So you've got nearly 4 pages of just different tests you can choose in their soil section alone. That's not even plant tissue and all the rest of it. So you can sort of see within a lab, you may have a number of different choices. Which soil test do I want to take? Which package do I want to order? So it doesn't really matter though which lab or test you choose. There's a similar process to follow to get the most out of soil tests. Now, it's good to use a professional lab that's accredited, and I will come back to that later. And I know someone watching this might go, oh, I've got to use an accredited lab, and that's definitely agree with it. But I'll come back to that sort of quality assurance side of labs a bit later on. But for now, the key thing is if it's a professional lab and it doesn't, you know, whichever test and lab you choose, there's a similar process to follow to get the most out of your soil tests. And I'm going to take you through that by pulling apart agronomic soil test and showing you the 5 key elements on a good test. Before I do that though, I just want to take you through for 5 minutes the fact that different there are different approaches taken to reading soil tests. So different agronomists, different soil scientists, different farmers and graziers all often have a slightly different opinion about what's important in a soil. So some people might think biology is the most important thing. Other people might think the chemistry is the most important thing. Other people think pH is a priority. Other people think, no, it's not. Organic matter is a priority, or calcium magnesium ratio is a priority. Everyone kind of approaches soils with their own understanding, and that influences how they approach reading a soil test. So in the world of agronomy, to sum this up, there are different opinions on the science and practice of how soils work. Are they just places for chemical nutrients to cycle? And other people would say, no, it's all biological, and other people are in the middle. And how plants grow. Do they take up just soluble nutrients, or do they interact with microbes and take up more complex carbon-based compounds and chelates, and how's that process all work? So there's different opinions on all of that, and on what's important in a soil. Some people think the cation balances are really important. Other people think they're not nearly as important. So you've got a whole spectrum of things. So there are different opinions on how to use soil tests, including the same soil test. So this influences a person's choices about what lab they want to use. Like, I know some people don't like to use certain labs, or they like to use, say, an overseas lab. I know someone that uses American labs only. What test methods that they will choose to ask the lab to do. Like, I have my preference for the carbon measurement as opposed to other methods. What numbers on a soil test that you should focus on? Is pH important? No or yes? Is calcium magnesium ratio? Which is the thing I should look at first, because that's my priority. And what benchmarks to use. And benchmarking is a really tricky part of soil health management, because I've got to decide, do I have enough carbon, or is my pH okay, or are my cation balances all right? What those soil salinity. I've got to decide what an appropriate target for my soils are for my climate, my soil type, and my enterprise. So that's not always black and white. There's a little bit of fuzziness and applied sort of local knowledge, landscape knowledge, agronomic knowledge in that. So I guess to sum up the different approaches, you've got two main approaches. You've got what I call conventional 20th century agronomy, which at its extreme is just about NPK, and you use a soil test to recommend fertilizers, the very sales-driven approach. I don't mean to lump all conventional or mainstream agronomists into that, because there are some really good holistic thinking, more integrative conventional agronomists, but the extreme end of it is just a sales agronomy, particularly fertilizer sales driven. And then we have at the other end of the spectrum, if you like, what's sometimes called regenerative. It used to be called biological agronomy. So, and there's different schools of thought within the biological world. You have the Albrecht, and then a slightly different Kinsey approach, and then you've got McHale, which is the SWEP approach. He owns the SWEP lab. And then you've got Haney, which is one some of you might have heard of. And then we've got organic agronomy approaches, which may be slightly different again, a very big focus on organic matter and legume management. And then what I call agroecological, which is kind of the approach we take in soil, land, food, which is kind of takes an ecological perspective of that topsoil and a soil systems approach. So the two views, I'll just differentiate between 20th century and a more holistic 21st century, which factors in the fact that your soil plant system is a biologically driven system with a very complex microbial plant interface, and that does modify the kind of black and white chemical numbers on a soil test. So as long as we use them with care and notice that they're not the whole story, then they are a useful tool. So with all that in mind, now I've just talked you out of using soil tests probably. With all that in mind, get your soil tests out and let's have a look at how we use a soil test, because if you build that confidence up, you can then use a soil test to manage soil health. It's not the only tool you have for soil health management, but it is a big one. So it's important to just get a feel of soil tests. And you can see these two cane farmers here that are just practicing assessing a soil their soil health or soil health on a couple of soils they have to deal with against a checklist. And that's really what we'll be doing over the next couple of weeks. So just a pro tip from Mr. Pro Tip Emoji before we kick off, and that is, if you find soil tests a bit confusing, if you're not comfortable or not familiar with them, then I find using highlighter pens can help. So have a different color for soil health and one for nutrients maybe, and that way you can just pull out key numbers as we go through it. And also, if you find you have a poor number, if you're scoring poorly on something like carbon or pH or whatever it is, or aluminium, then you can just get some of those stamps, the primary school stamps, and give yourself either a grumpy face or a happy face, depending on the rating of your number as we go. So hopefully you've got your worksheet, the action plan, and you can fill in that action plan as we go through tonight as well. So let's pull apart a soil test, and I'm going to show you the 5 elements or parts to a professional soil test. So if it's a professional lab that sent you a soil test, it'll actually have 5 elements on it. And once you understand how to find these 5 elements on a soil test, it makes reading them a lot easier. No matter where they're from, it doesn't matter which colorful bar charts are on them, or how many green leaves, or how professional looking the test is, or how busy it looks. It doesn't really matter as long as you learn how to find those 5 parts. Because the reality is that soil tests, and here's an EAL lab test from the guys at Southern Cross Uni, often they do look a bit confronting or technical, and they are technical documents. They can look a bit confusing and a bit overwhelming if you're not familiar with them, because they're not often laid out in a very user-friendly way. Now, some labs are better than others. EAL, they give you the raw data, which is fair enough, and their main, and the reason that a lot of labs don't necessarily lay it out in a really user-friendly way is because they're not real. Although they want to give you quality information, their focus is on doing a professional job of analysis and giving you those accurate numbers. Their focus is not necessarily on making it super readable for you. They certainly try to do that, the different labs, and EAL has a color coding system that you can probably see there on the left, and other labs have other ways, but they're often not done to a super user-friendly way, particularly for lay people like farmers and graziers who want to be able to read their test and make some informed decisions, but may not have the technical training that lab rats. I think I'm not going to get anyone upset if I call the lab rat. The guys that work in the lab, they're kind of, they're in the technical world all the time. Here's another one from a different lab from SWEP, and you can see it's laid out differently. But again, there's quite a lot of numbers and jargon on there as well, but doesn't matter. They all have these same key parts or elements to them. So let's jump into that and have a look. So if you have a soil test and you've got it out, then you can just follow along and practice as we go. So all soil tests that are really well done, professional, they usually have 5 kind of elements to them somewhere on them, and I'm just going to go through it very quickly and then show you with tests. We're going to practice pulling apart some tests. So the first thing that a good soil test will have, obviously, are the indicators. So they're the things, they're the aspects of the soil that you want to know about. So for example, the pH of the soil, it's an indicator that tells us about the acidity or alkalinity, or an indicator of organic matter in the soil might be the carbon percentage, or how much. There'll be indicators about phosphorus, maybe available phosphorus or total phosphorus. So there's different indicators, and you pay for, depends how much money and which test you order, you'll get either a few indicators or a lot of indicators. So usually you have to pay for the more indicators, but all soil tests will lay out the column with all the indicators on. The second thing a good soil test will have is it will tell you how they measured the different indicators. So for example, pH, the soil pH can be measured in a few different ways, but there's 2 main ways in Australia that soil pH is measured. One is a water method, and the other is a calcium chloride method. And they're 2 very different chemical extractions, and they give you different results for the same soil. So obviously you can't compare them. If I'm talking to you and my pH was measured in calcium chloride and yours was measured in water, we're not really talking the same language. So it's really important, and it's the same for carbon, it's the same for a whole lot of things, phosphorus. So there's different methods used. There's no Australian standard, although there are kind of industry preferred methods. There isn't any sort of regulated Australian standard. So it's really important to be clear which method your phosphorus was measured in, for example, so that you know you're talking the same language when you're looking at a benchmark or talking to an agronomist or talking to me or whatever. Okay, we're talking the same language. The third really important part of a soil test is what's called the unit of measurement. So for example, my home's in Albury in New South Wales, and I live 100 from a shop. Now you can say, Dave, is that 100 meters or 100 kilometers? How far away from the shop do you actually live? You don't know until I tell you the unit of measurement. Is it 100 centimeters? Maybe I live in the shop and I run a general store. No, I definitely don't do that. I'd be technically dead with all the other work I've got. So your unit of measurement is really important to know. How did they measure it, in kilograms per hectare or parts per million? That's really important, and a good test will have that on there. The fourth part of a soil test is obviously the results. You paid money to find out about the pH or the carbon or the phosphorus, or the calcium. So you want to know the actual number. What's the measurement? So that's obviously the result. And so a lab will obviously put that on. And believe it or not, labs do make mistakes from time to time, and you may get a gap in the test, and they didn't put the soil carbon number on there, or sometimes, very rarely with the professional labs, they've put the wrong results from another lab. There's been a mix-up in the lab. And finally, a soil test will have often, not always, but will have benchmarks or targets. So obviously, if I have a number, like my pH is 5, then I've got to know whether that's good or bad. So often laboratories will kind of give you a target or a benchmark, and we'll go into benchmarking in depth because it's not black and white, and those numbers on the soil test are not always regionally appropriate for you, and you need to be aware of that. Okay, so with that in mind, let's practice pulling apart some soil tests. And we'll do that by looking at soil carbon, because everyone's banging on about soil carbon, and it is a really important aspect of soil health. So not only are we going to be practicing pulling apart a soil test and learning how to read different soil health indicators, but we'll also just go through soil carbon. So by the time we finish this little part of tonight, one, we'll be practicing reading a soil test and pulling it apart, and two, we'll have explored soil carbon and how you measure it and how you evaluate it for a soil health perspective as well. So if you have your soil tests, feel free to grab it out and follow along. So just a quick refresher, what is soil organic carbon? So plants create organic matter as they grow, because obviously as they grow, they create sort of biomass above ground and also root volume underground, as well as exudates, the dribble their roots give off. So plants create this biomass, some of which ends up in the soil as what we call organic matter. So that organic matter is plant material, and it contains carbon, which came in through photosynthesis, and nutrients that the plant has taken up from the soil. So your organic matter is kind of carbon plus nutrients. So as that decomposes, which we know is what happens to organic matter in the soil, it decomposes. Some of it disappears back in the air through respiration, just like us when we eat carbohydrates. Most of the carbon in the carbohydrates we breathe out as CO2. When we breathe in oxygen, we breathe out CO2. So it kind of disappears. Otherwise, you'd end up like the Michelin Man, or even bigger than the Michelin Man. And some of it, though, turns into humus. So you can see this little soil here. It's a vanilla soil in North Queensland on a vanilla farm. It's a very unique situation, and it's a good example of humus versus respiration. The soil on the right has got 16% carbon, and it's built up from about 1% about 12 years ago when it was a cane field, a sugar cane field, which they often have very low carbon levels mainly due to management and environmental factors. And it's been built up through different management and mulching, etc. But you can just sort of see that soils have a bit of humus in them. Some have a bit more than others. 16% is very high. It's a very unusual soil. That's why we'd like to talk about it, because it's a great learning example. But most soils, like the soil on the left, which is 50 centimeters away in the interrow, has about 3 or 4% carbon. It's not getting the mulch, but it's not a cane field, and there are cane fields 30 meters away that have much lower carbon, again, just because they're more intensively managed and there's more respiration. So the key thing, though, about it, whether you're growing vanilla or cane or pasture, is that I need a certain amount of carbon for soil structure, for nutrient cycling, for water holding capacity, and for plant health. So I need to have enough carbon in the soil. Some of it will be humus, some of it will be labile organic matter breaking down each year and feeding all the soil biology in the party. You need a bit of both. You need to have enough. It's energy for the system, basically. So question is, do I have enough? Well, the only way to know that is to measure it. So this is how we start to measure. We use a soil test. So if you've got a soil test, feel free to find your organic carbon results. Now, I'm going to take you through a couple of examples just to show you. And what we're doing here is not only looking at carbon, which is important in itself, but we're pulling apart a soil test. So I'm going to start with this soil here, which is from AgVita in Tasmania. It's a horticulture paddock. And if you have a look at it, if I can make it move up and down, just bear with me a minute. There we go. So there's the lab, AgVita, and the soil test that we've requested is the Express Soil Pack from the lab. And if I look down there, if everyone has a look here, I'm just going to get the annotation tool going, also known as the squiggly doodah. You can see here they've laid out the results kind of in this table across here. So there's a lot of numbers, a lot of things going on. But if you have a look over here, they have this column called the analyte, or what they're analyzing, also known as the indicators. So there's pH, there's EC, which is salinity, there's carbon, here it is here, there's different things, phosphorus, calcium. So this is where they've laid out all their indicators. So you can sort of see they've put that first element of a soil test, the indicators, all in the left-hand side. So you can see here, here's our total carbon. So they've measured the carbon, and that's our indicator. And then you can see the second thing they've done is put the units, the unit of measurement. Remember, we talked about, is it in kilograms or parts per million or percentage? What's the unit of measurement? So they've told us the unit here. So in this case, the carbon has been measured in a percentage, the percentage of the soil. And then the third column, they're giving us our result. So you can see here, they've got our result. So this is what we paid for, obviously, and they've told us we've got 2.348 carbon in the soil. Now, they haven't told us, they've got this optimum range or benchmarking. So this is obviously where they've put the benchmark. Is your number good or bad in this part here? They've left it blank. Now, I'll come back to why they've done that, but you can sort of see for carbon, they haven't benchmarked it. So they've just given you the number, but you don't know whether it's good or bad. You don't know if you have to buy Dave Hardwick's brown coal, or you have to run around the paddock naked on the full moon, or you have to just buy heaps of compost. You have no idea. So you've got a number, but you've got to know obviously whether it's good or bad. But at the moment with this test, we don't know, and there's a reason they've done that, and I'll come back to that later. But just what I want you to focus on in the fact is that lab has laid out 1, 2, 3, 4 elements of what's needed. Now, the one that's missing is the method. So they haven't told us how they measured the carbon, because there's different methods. So that's important, because we need to know which method they use, so that if I'm talking to you or my neighbour down the road or a government officer about carbon levels, was it measured the same way? Because they give different results because they have different levels of accuracy, or thoroughness is probably a better word, because they're all estimates anyway. But yeah, so you can sort of see that's missing, but they have an asterisk here which may refer to some reference at the end of the report or on their website, which would probably tell us the method they used. But you can see it's not spelt out here directly. Let's have a look at another one. I'm just going to pull up another soil. This is from EAL, so the lab at Lismore, which is part of the Southern Cross University. It's quite a big lab. So here's EAL's lab, and you can see that they've laid it out. If I just shrink it down a bit for you, it's laid out a little bit differently again, but it's still in that kind of table format. And can everyone see that they've got this column here, which is parameter, or the different indicators? So when I spent my money with them, they've tested a whole range of things for me, and I'm hoping that it's the relevant things that I need, and it's giving me a good holistic set of indicators of what's going on. So and different tests give you different level numbers of indicators, but they call it parameter. And then if you have a look carefully in the next column, they have the method. So at this lab, they tell you very specifically which method they used. So for example, if we'll go to carbon in a minute, but you can see here for pH, they've got this 1 to 5 water, and they've even put the textbook that they get that reference from, which is basically the technical reference for Australian lab rats, soil lab rats. Sorry, I don't mean to be rude to them, because they're really professional people, but I'm just stirring everyone up. So that's the technical reference that the industry uses, and there's the method 1 to 5 water. So you can see how important they consider it, that you need to know which method. So they've given it a separate column. Then there's the results column here. They've got the sample, and then it's a pasture, it's a brachy pasture in North Queensland. And then you can see you've got your numbers. And finally, they've got this thing called indicative guidelines, which is obviously where they put their benchmarks. And you can see their benchmarks will change depending on what they think: clay, loam, sandy. They've actually got different numbers because, as I said, benchmarking is not black and white. It is often context specific, and that includes soil type. So you can see how they've laid it out, and they've used the word indicative so that they don't paint themselves into a corner, because they know that benchmarking is not black and white, and those benchmarks may not be applicable for every situation around Australia. They might be quite generic benchmarks. So that's the challenge, is making sure you adjust them. But let's look at carbon on this test, and it's not on the first page. You can see there's a hell of a lot of things there, but all I'm doing is hunting down the left-hand side indicator column, parameter column they call it. And on the second page of the parameter column, I'm just going to zoom in on this. Sorry, everyone. It's probably a bit small for people, depending on what size screen you're on, but I'm just used to having it a bit bigger. So if you have a look down, you can sort of see that halfway or a third of the way down the second page of this particular test result, they've given us our total carbon, which in this case is the total organic carbon. And then, so you can see they've given us our indicator. There's one. The first part of a good soil test is the indicator. Then they've given us the unit of measurement, percentage, and you'll notice that they put it in brackets. So whereas on the other test it had its own column, in this test, the unit of measurement it's in brackets. And then they've given us the method. They used the LECO method, LECO analyzer, to measure carbon. So that's the method. It's in its own column here. And then obviously we have our result, 6.4. So that's obviously very high. For many areas of Australia, that would be considered really, really, really high, or almost impossible, but not in wet tropical grazing on the Atherton tablelands. That's actually good, but I've seen higher. And in fact, that level is adequate for structure. It's up there on those heavy, high iron soils, ferrosols and their cousins. You need plenty of carbon to keep good structure and root volume you need in there. So you can sort of see we've got a number, and then they've said that for the clay soils, which I'll go on that benchmark, that more than 3.1 is what they reckon you should have. Now, we've got to rely on that EAL's benchmark is appropriate for us. It may not be. And my personal experience up there is that that's pretty low for that climate and soil type. For those pastures, if you're not getting over 5, then the soils remain quite tight, and you won't get the water infiltration from the heavy rain. So you can sort of see you do have to contextualize it. If that was a sugarcane field down on the coast, that would be a fantastic level of carbon, and you'd probably see pretty good soil. So you can sort of see there's another lab, and I'm going to do one more again just to pull apart this soil. But can everyone see we've got 1, the indicator, 2, the unit of measurement, which is next to it in brackets, 3, the method used, 4, the result, and then 5, we've got this benchmarking. Now, whether the benchmarking is appropriate for you, you have to always check, but they've given the 5 parts of a soil test. They've laid them out in a table form. And that's any professional lab, whichever lab it comes from, should have a similar thing. So let's look at one more from a different lab. So this is from Landmark before it came Nutrien Ag. So it's from the big lab. It's from Inside Tech. It's now, obviously, they're called Nutrien. They've changed their name again, Landmark. But yeah, this is a fairly recent, it's only a couple of years old test from through that lab, so different lab again. And if you have a look at it, again, here we go. We've got, over here, we've got they call it nutrient, but it also includes pH and carbon, so it's not just nutrients, so maybe that name's a little bit misleading. But here's the indicators in this column here, and I've noticed that the new tests from Inside Tech have broken it up into soil health and then nutrients. So they've actually tried to make it a bit more user friendly for everyone, which is good. So you can sort of see they've got their indicator column, and here's our carbon here. And they've even said 0 to 10, which is actually the depth that the sample was taken from. So, you know, they could have made that clear, because if you're not technically trained, you go, what does 0 to 10 mean? Which would be a fair comment. So but here's our indicator, organic carbon. And you'll notice that in the brackets, they've put Walkley Black. So Walkley Black is the method, the way they measured the carbon, and it is different than the LECO method, which we just looked at on EAL. It is a different test. So it's a little bit like me counting the kangaroos for you in one of your paddocks, and I just go to the fence and lean on the gate and count kangaroos while drinking a soft drink in the evening. So I might see 4 kangaroos. It's a very different method than if I get a drone with infrared camera on it and I fly the paddock for an hour and count 400 kangaroos. The level of accuracy will be different because the way I've measured it is different. So they all have their pros and cons, the different methods, but here is, they've given you the method. There's the percentage, so the unit of measurement's clearly given. There's our result. Well, that's good. They've given that really clearly in a column. And then they've given you a kind of evaluation or benchmarking system. And they're saying that you're in the red, which always means you've got to spend money according to commercial agronomy, if I'm in the red, or it means I've got a weak link that is losing me potential production. So that's why they use red. So you've always got to obviously read them with a bit of caution, especially if a sales agronomist is the one that's giving it to you. But, you know, that's the intention of it, is to sort of tell you this is what we think, this is a weak link, it's a low or it's inadequate. So they're saying that the carbon is low at 2.19, and in fact they're also giving you a target of between 3 and 7. So obviously they're saying, by that, they're saying there's a bit of a wide range that you could aim for, and just knowing carbon and, you know, being obviously in this game a bit, the lower end would be for sandier soils where they can't store as much carbon, so that lower end is probably appropriate for them. And the higher end would be for your heavy clay soils that actually need a fair bit of carbon if they're compacted to open them up and keep them functional from a structural point of view. So they've got, you know, they've got a range there to hit, but we're below the range, so they've got to buy my brown coal at this point. If we trust the benchmark. So we may not trust the benchmark. And the other thing is we need to look in the paddock, because sometimes at that 2% you go in the paddock and the soil is quite well structured and has good root volume. Well, maybe it has enough carbon. Just because the soil test says it's a bit low, I also have to check in the paddock the actual field conditions. It's a bit like when you go to the doctor and they say, oh, the blood tests tell me you've got this, but then you look at the person and they obviously don't have that. So, yeah, you've got to double check your soil tests always. So that's an example for you, though, if I'm getting a bit off topic again, as usual. That's an example for you of where we've got the indicators, part 1 of a good soil test. Then they've got the method used in brackets, so that's 2, the unit of measurement, 3, the results, 4, and then a benchmarking system. So, and some of the labs, some agronomists will run the numbers through a database for their industry. So, for example, if you're in grazing, or this is a Western Victoria cropping paddock, the agronomist might have run the numbers through a database so that the results have been made, the benchmarking is regionally appropriate, and that's what that back paddock software does, that SoilMate. So the agronomist or the company has paid for that software so that they can get benchmarks that are appropriate for the crop, the enterprise, the soil type and the rainfall. So you can kind of see there's another example from a different lab of the 5 elements of a soil test, and at the same time we've been looking at carbon, which is one aspect of soil health. So just to refresh on this carbon story, if I can get myself organized. No, just hang on a minute, everyone. See if that works. Yep. Organic carbon is measured as a percentage normally. This is the unit of measurement. Sometimes they convert it to a weight, so milligrams per kilogram, and you have to do that if you're doing a carbon project because you get paid in tons of carbon, obviously. But to do that conversion, you need to know the bulk density of the soil. You need to know it's the weight of the soil. So you can't convert it from that. So normally it's done in percentage from agronomic points of view. The second thing is there's different ways it's measured. So we've seen one lab had Walkley Black, one lab had LECO, one lab didn't tell us specifically the method. The first lab there, the AgVita, didn't tell us. So it is important to know because they are different tests and they give different numbers. The LECO is the more modern method. Walkley Black is still widely used, but the LECO is the more modern, probably a bit, or definitely a bit more accurate method. And it is the one that's used for the carbon farming projects. So you can see that they've chosen that one because it is using a fancy bit of 21st century technology, if you like, whereas the other two are kind of mid 20th century technologies that are they're helpful. They give you, they give you something you can make management decisions on, but they're probably they're not as accurate. They're probably a little, starting to show their age a little bit, if that makes sense, without getting myself into too much trouble. Okay, so finally you'll have a carbon number on your soil test, and you've got to work out whether it's good or bad. And I talked you through that Atherton tablelands, high rainfall grazing soil up on the Atherton of far north Queensland. At 6%, I'm saying that's okay. If it was at 3.5 to 4% in that soil type, just knowing how those soils react with carbon and root volume, it would be not enough. It would be a tight topsoil that would have poor infiltration of the heavy tropical rains. But over about 6%, and that's the certain level of root volume kicks in, they really, the friability or the porosity really increases at around that threshold. So but that 3% would be great in a Western Victoria sandy cropping soil. 3% would probably be quite a good amount of carbon in there, and you may not be able to get much more depending on your rainfall and soil type, etc. If you're cropping. So you can sort of see it is relevant, but we need to find a benchmark, which I'll come back to in a minute. And this benchmarking is the tricky part of soil management. So if my number is below my target or my benchmark, then obviously I have an issue. I don't have enough carbon, means I'm not getting good water holding capacity, probably not good structure. Nitrogen management will be problematic because nitrogen lives in organic matter. It doesn't live in soil solution. That's less than 5% of the soil nitrogen is in the soil solution. It's all in organic matter. So if I don't have any organic matter and carbon, I won't be able to hold my nitrogen very well. So you can see that low carbon is a problem. And so if it's a really low, I've got a major problem that I have to fix. So we'll come back to benchmarking in a minute. So hopefully that's all made sense to everyone. I haven't seen any chats come in. So that either means you're all sleeping or you've all just had enough, or you're hopefully following along and making notes. And so just a final thing before we move on, and that is, what's the relationship between soil carbon and soil or matter, organic matter? So I'll just clear this up. So the first thing is that plants create biomass as they grow, plant biomass, which contains carbon and nutrients. So when you're holding a stalk of a crop or grass in your hand, it's got carbon in it and nutrients, as well as some water and oxygen as well. So that carbon plus nutrients plus water equals plant biomass. And when that hits the soil and becomes organic matter, it contains those three things as well. So the lab actually measures the carbon in it. That's how they estimate the whole thing. They estimate the carbon side of it. And then we say to ourselves, yeah, we know they've measured carbon, but we know that that material or that soil organic matter is more than just carbon. There's also nutrients in it. So you can kind of estimate the overall organic matter from the carbon number. So let's have a look at that in real life. It makes it easier. So here is the Express soil, the Ag Vita soil, again, that horticulture paddock. And we can see that they measured carbon. Here it is here. They measured the soil carbon. A percentage, 2.348. We'll just go with 2.3. All good. Give you the 0.048. And we don't know the method they use. But we could find that out by checking with the lab or the reference at the end. So then what they've done is they've multiplied that by a conversion factor to turn it from carbon into organic matter. Does everyone see that? So they haven't actually physically measured the organic matter. They actually measured the carbon. And then they do a conversion, which is a standard conversion all the labs do. And then they've said, well, we're going to also give you your organic matter number, which is related to carbon, but it's carbon plus the nutrients in that material, in that organic material. So they've done that, and then that's the one that they've benchmarked. Does everyone see that? Instead of benchmarking carbon, they've benchmarked organic matter. And they're saying that at 3.6 in this horticulture paddock, you've got a satisfactory level of organic matter, which automatically would say we've got a satisfactory level of organic carbon. So that's just an example for you how the two are related, organic matter and carbon. So on your soil test, it may have carbon, or it may have organic matter, or it may have both. So you can work off both. But again, if you're talking to someone in the pub, oh, I've got 7% organic matter, and they're talking carbon, oh, I've got 3% carbon. You're not talking the same language. So you need to be really clear about that kind of thing when you're talking soils and soil health with people in general. Okay, so what I've done there, apart from talking about carbon, which everyone likes to talk about, and it is important, but the main thing I was hoping to get across in that little session was the fact that a good soil test, here's another soil test from a sugarcane field, a good soil test will have these 5 elements. So sometimes it doesn't have benchmarking and you have to do your own benchmarking, and that's all good. But generally they have 5 different key elements on them, even if they're laid out differently or they got bar charts and things. And so once you sort of learn how to hunt down those elements and double check, okay, here's my pH. Is it the water pH or the calcium chloride pH? The method, okay, here's my benchmark. Is that irrelevant? Once you learn how to pull apart those 5 elements, it helps you manage, read a soil test. So hopefully that's given you a little bit of a feeler for it. And the second thing is obviously you learn how to pull apart a soil test like these Northern Territory guys are doing as part of our Digging Deeper boot camp, face-to-face soils courses. And you follow a logical process, which we're kind of going through in this course, then it'll help you read them and make sort of better decisions around where and how to spend your money and your resources. But you'll build your confidence in using soil tests as a tool to manage your soil asset. And I'm certainly not saying don't use your agronomist or use agronomists, but you'll just be a more informed partner in that process, which I guess will help everyone. Not just yourself, but probably the agros as well. So I'll just quickly now, so hopefully that's given you a feel, and we're going to practice reading different things, pH, carbon, nitrogen, exchangeable aluminium. We'll practice all those things over the next couple of weeks, calcium, magnesium ratio, all of that stuff. So you'll practice pulling apart soil tests. So if you haven't quite got it, don't stress out. But what I want to do is just spend about 5-6 minutes talking about soil benchmarking in a little bit more depth, because probably by now you'll see that it's not always black and white. It is often context specific. So the key thing when you're looking at your results from your test is you've obviously got to work out if the numbers are good and bad. So you need to identify that target or benchmark. And so labs will often give you those benchmarks like we've seen just before. And so if your number's good, then you're all happy. If it's marginal, then you go, it's not too bad, but do I need to spend money? And if it's really low, like carbon is low, like we saw on that test from the Wimmera, Western Victoria, then obviously I've probably got a soil constraint. And a soil constraint, as we'll see, is any soil health issue that inhibits soil function and root volume. So anything that inhibits soil function and root volume, and I'm not talking about a nutrient, because I can have a low fertility soil that has really good function and plenty of root volume and structure. It just may not be as productive as I want it to be because I'm doing agriculture, but it can be really healthy. So yeah, that's the benchmarking is either going to be good, marginal, or poor on different things. And identifying benchmarks can be tricky, like carbon. It's not black and white because it depends on soil texture, climate, rainfall, a few other things. Some benchmarks are relatively fixed, but some are quite relative. So ground cover is quite a black and white one. If you ain't got close to 100% ground cover, except if you're in semi-arid Central Australia and the really low rainfall pastoral country where you might say 70% is your target, you need 100% everywhere else. I'm sorry to say. It's fairly black and white. You'll really get improvements in your soil and your whole enterprise if you keep ground cover. But some other ones are not as black and white, like pH, because some plants and grasses and crops are more tolerant of a lower pH or a higher pH. So some benchmarks are a range and available phosphorus, for example. You might have a lower input, a moderate output grazing operation where you don't need as much phosphorus because you're not trying to get the really high output that someone else down the road is. They might be spending more money to get that output, but they may not be as profitable. So a lot of benchmarking is relative, although there's usually a minimum or a maximum that you know if you go under or over, depending on the benchmark, you probably got problems. So the benchmark needs to be relevant. It needs to be realistic, like that 16% carbon on that vanilla soil. I'm not saying that everyone can achieve that. That was a very unique situation, but even in the wet tropics, it's very hard to get those high levels of carbon because respiration and decomposition rates are so high, but they were definitely able to achieve it, not that they were aiming for that. And sometimes the soil benchmark is a range, like pH. I need my pH to between 5.5 and 7 or whatever it is. Sometimes it's a minimum, like I want at least this much carbon in my soil, nothing less than that. And sometimes it's a maximum number, like for example, salinity. You usually don't want it to be higher than a certain benchmark. So too much is bad. So you have a kind of maximum amount that you want. So and sometimes just thinking of benchmarking different things as we go through the rest of the course, you might say, well, let me set a target initially, and then if I get to that target, let me then try and improve it a bit more. Because it's an investment, of course, you're investing time and money to improve soil health issues. So sometimes you have to do it in a staged approach. And sometimes as the soil improves, the potential for further improvement can be ahead of you. So, you kind of do it step by step. Or you can just buy brown coal from me and I'll sell you brown coal and you'll fix your carbon levels straight away. I am joking, so if you're watching this and you don't get my sense of humor, don't be surprised, no one does. So where can you find soil benchmarks? So yes, you can get your soil benchmarks from soil tests, definitely, but there's other places. So departments of ag studies, commercial agronomists that have experience in the district, trials and industry research, and your own experience or your peers down the road, like other farmers or graziers in your area who have similar soil types, similar rainfall and soil type, doing the same enterprise. What are they achieving in those soils? Are they, do they have much deeper root zones and better structure or higher carbon, or is their pH reached a good equilibrium through that management that they're doing? If they're on the same soil type and similar rainfall and enterprise, then they're a really good reference point for you. So there's different places you can get benchmarks from, and you really need to be careful and make sure it's a relevant and realistic benchmark for you and your situation. But the other thing to remember though is don't just go off soil test numbers. Really make sure you're validating and checking with what's happening in the paddock. That's so important. Just because you've got reasonable carbon on the soil test, you might go out and it's just a thatch with compaction under it. So, just because the carbon on the test is good, the soil doesn't have structure here. Sorry, I'm not going to give it a good score. So the question for benchmarking carbon, for example, is do I use the carbon indicator or the soil organic matter number? And so when you're benchmarking, obviously, and with carbon, using a specific example, the target's going to depend on climate, soil type, and your enterprise. I'd suggest you that at least 2% in lighter textured soils and 3% in the heavier soils at a minimum is a reasonable target to sort of get to. And then, so if you're, if you're above your target, that's great. If you're marginal, then you're going, maybe it's not too bad, but I need to do a bit of improvement. And if it's poor, you've got to say, right, what have I got to do to improve this? Because I'm losing potential yield for sure. And it's costing me money, and I've really got to lift my game. And just by chucking out fertilizers is not going to improve it. Those fertilizers will be used really inefficiently if carbon's really low. So it's not going to solve your problem. You're just going to be burning more money. You'll get a bit of a result in growth, but you'll be using way too much fertilizer to get that result. So yeah, you've got to be realistic and focus on soil health at least at the same time, if not before you worry about all the fertilizers and all that sort of stuff. So I guess the question with this one, because this course is about rebooting your soil health. So once you've identified an issue, you've got to actually do something. And so I guess the question is, what can you do to improve soil carbon levels? And the answer is, if you're in grazing, it's to just change your grazing. So you can see from this trial out of the US where they cut the grass to 2 inches every week, every second week, and every 4 weeks. You can just see the extra root volume where the grass had more recovery time, which gave it more time to put carbohydrates into root reserves, and that leads to more soil organic carbon and organic matter. So you can just sort of see that's the big tool you have, is to manage your plants, and particularly your grasses, but all the plants, the broadleaves, to build as big a root system as possible. And if you're cropping, then it's about how can I build root volume, minimize compaction, minimize disturbance, get plant diversity going, get some legumes to bring nitrogen in, because nitrogen helps all the soil biology and the soil microbes utilize the carbon from the plants and create all their compounds, and then that stimulates the roots, and then you get more root growth, and the whole party just gets wilder and wilder and wilder. And then it's all going along fine at that point. All you have to do is put more whiskey on the bar, which is just photosynthesizing plants basically. So there's different things you can do, and I'm sure some of you are exploring some of those. But you're trying to minimize respiration and maximize that humus formation and root volume. So if there's any burning questions on carbon, but more importantly than carbon is on soil tests, because we will come back to soil health and talk about carbon a bit more. But how to use a soil test and those 5 elements. Feel free to throw it into chat. I'm going to keep rolling because I'm just mindful tonight is the night where I've got a lot of ground to cover, but hopefully I'll have a bit of space at the end, and I haven't seen any more questions come in, so I'll just keep rolling. But if you do have a question specifically around how a soil test is laid out, etc., feel free to jump in. So let's just jump across now to, I guess, the core part of the course, which is managing soil health. And I've already kind of given you an example through that reading the soil test session just before, of using a soil test to identify a soil health aspect, i.e. carbon, and then thinking about if it's good or poor. So that's really the process you follow for managing soil health. But let's just go back through that again from that different angle of soil health. So really there's 3 steps to managing soil health. There's measuring your soil health, like we did with carbon just before. Then there's assessing that result against a benchmark, which we did before with carbon very briefly. And then there's taking action, which I just talked about. The best action is to buy my brown coal. So you've got 3 steps to follow when you're managing soil health. Measure the different aspects of soil health, assess those results against a benchmark, and then take action if you've got a soil constraint. So here's a friend of mine, Wes Spencer, is looking at a paddock cereals where he's put compost out to try and improve a poorly structured, tight, hard setting, heavy clay soil in northern Victoria. It needs a bit of carbon and needs to improve its structure. So we can use a soil test to do that, as we did with carbon. And when we identify an issue like low carbon or poor pH or salinity or whatever it is, we call those things soil constraints. So something like compaction, which is happening here in Wes's paddock, that, or poor structure, that soil constraint you can't get from a standard soil test. You've got to get out with a spade and evaluate that in the field. But some things we can use on a soil test, we can identify on a soil test. So a soil constraint then is any non-nutrient aspect of your soil that is limiting the growth of plant roots. So anything that stops your plants from expressing their full root potential, genetic potential, is a problem. Here's a bit of a radish doing a bit of a busting up job on a bit of a tight dairy soil, and anything that's limiting the functioning of the soil system. So inhibiting cycling of air and water and nutrients, causing all the soil community to be unhappy, that is a soil constraint as well. And it's not it's not a nutrient. Nutrients, yes, they help productivity, but a lot of the time they don't impact functioning of the soil. Certainly they can improve soil functioning by growing more plants and therefore more organic matter and more energy for all the soil community, but I can have a high functioning soil on a low fertility soil type if I manage the plants and don't get compaction and keep the air and water and plant diversity there. It may not be very productive, but it can be quite healthy. So if you have soil constraints, you're losing potential income because your plant productivity is not at its potential, and it's going to cost you money to fix. So you got a double whammy. So no matter what type of vehicle, if you're going to buy a secondhand vehicle, no matter what type of vehicle it is, you want to know it's in working order and can do a job for you. So you'd be going through a checklist to check that that vehicle is in good condition. Number of wheels, body condition, does the gearbox, is it making a noise? Black smoke coming out the rear end, is there windscreen there, or is there an engine there in this case? So you'd have a checklist, is the vehicle in working order if I'm going to buy a second-hand vehicle? And I won't worry about how much fuel's in the tank, because I can, if the vehicle's in working order, I can get a jerry can and fill up with fuel. So that's not going to be a deal breaker. But the condition of the vehicle will be a deal breaker if it's in poor condition. So it's the same with the soil. You need to keep it in good condition for the long-term productivity, because it does all these things for you. It captures water, cycles nutrients, provides a good environment for the plants, minimizes soil-borne diseases, etc. So you've probably got a few different soil types, but they all need to be kept in good condition, whether they're sandy, heavy clay, anywhere in between, red soils, black soils, crappy, shitty soils. It doesn't really matter. You've got to keep them in good condition. So we've got a soil health checklist in the same way that you've got a vehicle inspection checklist. There's a checklist for soil, aspects of soil function and soil condition, and all you need to do is follow that checklist to identify any weak links or soil constraints. So let's go through that checklist, because it's not too long and you've probably heard about quite a lot of them. So the first one is ground cover and litter. Then you've got soil structure. And I'm not going too much into any of these because you can't use a soil test for these. So they're kind of, you're going to have to get that by watching YouTube videos and going to workshops. But basically, surface condition, do you have crusting on the surface? Root activity, how deep are the roots going and how much volume of roots are there? Are the roots healthy, or are they got soil-borne diseases chewing them like nematodes? Soil organisms, do I see earthworms or ants or other invertebrates in the soil, springtails and mites? So is there a diversity of living things there? So that's all part of your checklist that a soil test can't help you with. But the other tool, the soil test tool, there's certain things on that. And we've already done the first one on the checklist. So we've already done soil organic carbon or organic matter. So we've done that earlier tonight, and you can see how we did it. We found the checklist indicator, we found our results, we checked the unit of the way it was done, the unit of measurement and the method. Then we said, righto, what's my benchmark? Find a benchmark, and then we've evaluated and said, yep, I've got enough carbon, or nope, I haven't got enough carbon. So that's the process. So you can sort of see the checklist, the soil health checklist that you use from a soil test. And it's not a lot of things. It's the carbon to nitrogen ratio, it's the pH, the soil salinity, and then the big kahuna, which people get quite hot under the collar with and or confused about, and that's cation balances, and we'll go through them next week. We'll spend the whole session on cation balances, but for now I'm just going to tackle the next thing on the soil health checklist, because that's all we're doing now. And if you've got a worksheet or the action plan printed out, you'll see that I'm just working down the checklist. We're going to go through what's called the carbon to nitrogen ratio, which is another really important aspect of your soil, and when that influences the whole soil function. So that's why it's a soil health issue. All of these things that we're looking at can, depending on the context, influence the whole soil function and root activity. So that's why they're key parts of your soil health. So let's practice one more thing tonight. I know I've covered a lot of ground, so hopefully everyone's keeping up. We're going to go through the second thing on a soil health checklist, and that's something called the carbon to nitrogen ratio. So that's what we're going to jump into now. It's a really important quality or property of your soil that influences the functioning of the soil system. Okay, and let's practice using our soil tests and going through them. So what is the carbon nitrogen ratio? So it's not only the quantity of organic matter that's important in the soil. So you can see here you've got a soil on the right with 16% carbon and one on the left which is 50 centimeters away, the mowed interrow at about 3 or 4% carbon. It's not only how much organic matter is in the soil, which we measure with carbon, it's also the quality of it. The quality is also really important. So you might have a lot of organic matter that's really woody. So it's really high in carbon and not much nitrogen. So if you're into grazing animals, you'll know that it's all about digestibility of feed. How digestible is the feed? So if the material is really woody, like these leaves here in this forest in Western Victoria, then as the organic matter enters the soil from the plants, either from leaf fall or roots underground, it will break down really slowly because there's not much nitrogen around for the microbes. So there's plenty of carbohydrates, not of protein. So the balance between those two in the organic matter is quite wide. So that slows things down. Fungi are really happy. They can kind of eat it, but they eat it really slowly. So what that does is it slows down the cycling of nutrients through the soil because it's all the life in the soil eating each other or eating organic matter that actually cycles a great proportion of your soil nutrients. It's not the only nutrient cycling pathway, but it's a really important one. And it also slows down all the bacterial activity, and they help, and fungi activity and earthworms and all those guys, which help with soil structure. So, and it also can create more humus because humus kind of often forms, not always, often forms in that slow, high woody type organic matter pathway. So when it's really woody, we've got too much carbon, not enough nitrogen, we would say that our organic matter quality is a bit too woody, and vice versa. If your organic matter is too much nitrogen, we usually say it's hot. So like chicken manure, which everyone's usually smelt, and it smells like ammonia. The reason it smells like ammonia is that pile of chicken manure, there's lots of bacteria trying to eat it, trying to decompose it, and the bacteria are gobbling it up, and they're getting their carbon and their nitrogen to eat it because they need a balanced diet. Except there's not enough carbon for them. There's excess nitrogen. So in a pile of fresh manure that you're smelling ammonia coming off it, which is nitrogen, that's telling you that the bacteria don't have enough carbs. So that they can't eat the nitrogen because they haven't got enough carbohydrates to go with it. Too much pasta sauce and not enough pasta. So in that case, the excess nitrogen just disappears. So that breaks down really quickly when there's too much nitrogen, and unfortunately you'll get respiration and very low soil carbon because it's all breathed off. As they decompose so quickly, they just breathe the carbon off as CO2. So you'll have a high respiration rate, and this is a paddock in central Queensland that has a very hot C to N ratio and very low organic matter. It's very hard to form humus in that situation, and there's various factors driving that. I won't go into them tonight. There's a number of variables that are pushing that respiration rate up. The carbon nitrogen ratio is really important because it influences the speed of nutrient cycling in your soil and the development of your soil's humus, or long-term soil carbon sequestration. If you're a bureaucrat, sequestration of soil carbon. So it is an important aspect of your soil. tells you the quality of your organic matter, and you need it to be in a reasonable range. So again, you need a reasonable balance in the quality. I don't want it too woody and I don't want it too hot. There's a kind of sweet spot in the middle where the soil will function reasonably well. So I need to have a certain amount of organic matter, and I need the organic matter to be a reasonable quality, digestibility. So you're looking for the total carbon or the carbon and nitrogen ratio on your soil test, and not all soil tests measure total nitrogen. So that's a problem. So here is this horticulture soil again. Here it is up here. So the AgVita test, the horticulture paddock in Victoria, and you can see they have measured total carbon, which we saw before. Then they've also measured total nitrogen. Not available nitrogen, total nitrogen, which is in the organic matter. And then they've said, righto, here's the ratio of the two. Everyone see that? There's our ratio. It's a ratio, and it's 12.662. I'll give them the 0.662. It's 12 to 1. So that means 12 carbon for every 1 nitrogen. So that's their ratio. And for some reason, they haven't benchmarked that, although these guys I know do talk about, ideal ranges for that. But at the moment, we won't worry about that because they haven't given us the benchmark, and we'll look at that on another test. But basically 12 to 1 is the quality of my organic matter. So just remember that number, 12 to 1. So if we go to another test from a different lab, so let's go to the Wimmera test out there with the landmark test. They haven't measured, if I look down my indicators down the side here, they haven't measured total nitrogen. I've got total carbon, this one, but they haven't done total nitrogen. So I can't get that ratio for this soil test. And a lot of what I'd call conventional agronomy tests don't measure total nitrogen. They can do it if you ask for it. The labs can, most of the labs can do it, no problem. You need to ask for it because it's not often done as part of standard agronomy. And I'm not sure why, because everyone agrees that it is an important aspect of soil, the C to N ratio, but it's often people focus on the kind of soluble nitrogen when they're making nitrogen decisions, nitrogen being a difficult nutrient to kind of estimate and manage. But anyway, it's not on that test for whatever reason. So let's go to an EAL test. I'll pick another one. We've been looking at that North Queensland soil. Here's some soils from the Northern Territory, from Catherine. There's 4 soils on this test, 4 soil test results, but don't worry too much about it. But if I go to this EAL test, you can see near their carbon, they have also measured total nitrogen, and then they've given the ratio of the two. So there it is there. The first soil is 11.9 to 1. The second soil is 12 to 1. The third soil is 16.9, so 17 to 1. It's a little bit more woody, a little bit more carbon in the organic matter than nitrogen proportionally. So it'll probably be cycling a little bit slower, but not very slow. But you can sort of see they've given this key, not just the quantity of organic matter, which is really low in these soils. These are Northern Territory soils near Catherine. They've got 0.48% carbon, 0.58% carbon, and 0.52. You can see they're quite low in organic matter and carbon, but the ratio, whatever organic matter is there, has this balance of C to N, as we can see. So that's just some examples for you from a few different tests from different labs. And so I'm not sure, because you guys might have different soil labs and stuff. So it's not the available nitrogen, it's the total, and not every lab will measure it, or sometimes people forget or don't ask for it, but you need the total nitrogen. Just for those of you that are interested in the Haney test, which is a bit of a different test out of the US, which people do use. It's starting to be used a bit more. Gabe Brown uses it, and a few of the regen rock stars and a few other soil health focused people in the US have used it for a while. So we've been using it a little bit in Australia, trialing it, try to learn and understand it a bit. But here's a Haney test. I sent this one away to America based on Gabe Brown's recommendation when I was lucky enough to meet him. But it does C to N ratio as well. And you can see here, it actually does it twice. It does or sorry, it doesn't do it twice. It does the water extract. It uses a different method, but it does organic nitrogen and organic carbon, total organic carbon and nitrogen, and then it does the ratio here. So it's a different method. It's water extract, which the Australian labs don't use. They use a total with the LECO. So this is the water soluble, if you like, fraction or extractable fraction of the carbon and nitrogen. But it's trying to estimate the same thing, how readily nutrients are cycling in that soil. It's kind of trying to estimate the same thing using a different method for C to N ratio. Okay, so the unit of measurement is a ratio, obviously. There are a few different methods, and I've just mentioned the two. Total carbon to total nitrogen using a LECO is the common one, the fancy new machine, combustion machine and then analyzer. And then you've got your soluble carbon to soluble nitrogen, which the Haney test uses. And so we've got our ratio. So the question is, if you have a ratio 12 to 1, 16 to 1, what's good and what's bad? We need to have a target or a benchmark, and I'm just going to give you a general range, which is fairly universal. It's one of those targets or benchmarks for soil properties that is quite actually universal. The reason is that it's a biological threshold, mainly of bacteria. So when there's more than 20 to 1 carbon, 25 to 1 carbon to nitrogen, bacteria run out of nitrogen. They run out of protein, basically. So it slows down bacterial populations and therefore slows down the kind of nutrient cycling and the very active part of my soil. The soil's getting a bit sleepy, fungi are taking over. It's getting a bit more Joe Biden-ish rather than Donald Trump-ish. Sorry, I had to throw in a joke there. It's not as lively, but it's certainly ticking along, don't get me wrong. But for agriculture, the nutrient cycling may be a bit slow when it's over about 20 to 1. And under 10 to 1, that soils generally start to have too much nitrogen. They are too hot. They're too volatile. They're cycling their organic matter very quickly, and they're respiring the carbon off at quite a high rate. So it's very hard to build humus when the soil is that hot. So under 10 to 1. So chicken manure runs around, fresh chicken manure that smells like ammonia can be like 6, 7 to 1. So you can sort of, that gives you a bit of a feel for how it compares. So it is an ecological threshold, and so it's fairly universal. Sometimes you'll see 25 to 1 as the upper limit. But I'd suggest for agriculture, if you're growing crops and pastures and horticulture crops, you really don't want it to go too much over 20 to 1, or you may be slowing down nutrient cycling a little bit, which can be a bit of a risk for yield and growth of fruit, things like that, etc. So, and sorry anyone that got offended with mucking around with a joke about the president. So I didn't mean to. It's just a way to muck around a little bit. So don't take it too much to heart. Okay, so carbon and nitrogen ratio, like any other soil health aspect, if you're within your target range, then that's all fine. Make a smiley face against your result. That's good. You're keeping your soil in a good equilibrium. If you're kind of marginal, then you've got to ask yourself, is it really an issue for me? And at that point, you can look at other aspects, other indicators or symptoms of the soil. Maybe it's a little bit marginal, the result, but the soil seems to be going well. It's well structured. The plants are growing well. There's no soil-borne diseases. The nutrients are cycling quite well. So maybe it is okay, even though the number on the test is marginal. And if you're well outside your range, like 25, 30 to 1, then I'd suggest you're too woody and you need to get more legumes into it. That's the best way, of course, to build nitrogen in the topsoil. So you've got to ask yourself if you've got a constraint and how do you improve it. Here's a young avocado orchard in North Queensland. And you can see they mulch the trees, which really helps them for a number of reasons: disease management, water management, just protection from heat in summer, nutrient efficiency, a whole lot of benefits. But you can see they're growing grass in the interrow, which they will mow and side throw as a mulch under those trees at some point. And if they were to mow it now while it's green, when that photo was taken, then that mulch would break down quite quickly because it's fresh, it's got a high nitrogen content. The microbes will gobble it up and it'll disappear and decompose. So it won't give you as much benefit as a mulch. If they let that interrow hay off in the dry season and it just goes all rank and dries off, there'll be a lot less nitrogen in the material. So when they side throw it, mow it and side throw it, then it will be it will take a lot longer to decompose because there's not enough nitrogen in it. It'll slowly rot down with fungi, and it'll give you more of a mulching effect for longer. So I'm not saying one is better than the other. There'll be different times a year where you might want to throw it in green to prime nutrient cycling in the soil, and there might be times when you want to throw it in brown to give you a longer mulching effect. So you can kind of see the example of the C to N ratio above ground, but that influences the soil C to N ratio, the soil organic matter as well. And I know those of you into cover cropping and multi-species cover cropping and thinking about your balance of your legumes to your cereals, are thinking, we'll often think about carbon to nitrogen ratio as well. Okay, you can modify it through grazing. So for example, in this pastoral Northern Territory operation, if you're grazing the grass when it's rank all the time, well, it's going to get more lignin and woody, and the C to N ratio will go to woody. And if I haven't got legumes in there, so grazing the grass, keeping it in that stage 2, high photosynthesis, greener, it's better feed quality, obviously, but it's also going to keep the soil C to N ratio a little bit more in that equilibrium. If you let things go too rank or woody, you can really slow that soil's nutrient cycling down to the point where it's not as productive. And so what can you do in cropping? Well, obviously making sure you've got a good balance between legumes and your other crops, just to keep that nitrogen component of my plant material and therefore soil organic matter up. And so that I keep that good C to N ratio, which keeps nutrient cycling, helps me really manage that side of the soil health. Okay, so that's C to N ratio. I might pull it up and then just open it for any burning questions, but hopefully you can sort of see in that case, we've used a soil test again to pull apart a soil test, and we can find the carbon to nitrogen ratio on a soil test. If I do it one last time on this grazing paddock in North Queensland, the second page of the EAL test for this particular test that we ordered, they have the total carbon, the total nitrogen, and then they've given the ratio, and then we can say, all right, we know we had 6% carbon, which is quite high, organic matter and organic carbon, and here's our ratio, 13 to 1. Now EAL, I beg to differ with them on this particular benchmark. I disagree that 10 to 1, between 10 to 1 and 12 to 1 is kind of the only optimum. I think having seen a lot of soils function really well a bit outside that range, I would say that between 10 to 1 and around 20 to 1, you still get soils function really well. Certainly that range is really good, but I think soils are living ecological systems, and they do have fuzziness or ranges or a bit of flexibility in them, and so they will function quite well within limits that are sometimes a little bit, the tolerances are a little bit wider than sometimes we put on our benchmarks as humans. So you do see soils function really well at like 16 to 1, 18 to 1, but you definitely have to be mindful of that ratio. Okay, so that's pretty much it. I think I managed to get through it, which is a miracle because usually this one goes over time. So I hope you've got a bit of food for thought there tonight. We've covered a few really important things on this second part of Reboot My Soil Health webinar series. We looked at soil tests and I pulled them apart for you. And then we looked at the different approaches to them, but really those 5 elements of a good soil test: the indicators, the unit of measurement, the method they use to measure the different things, that's really important, my results, and then benchmarking. So you can see that benchmarking is not always black and white. For some things like C to N ratio, it's a fairly universal one, and ground cover, but there are other things like pH and carbon, as you'll see, that are a bit more rubbery or context specific. And then we've just started to use a soil health checklist, and we've looked at carbon, organic carbon, and C to N ratio, and they're just 2 key things on a checklist. So if you think of your soil as an asset and you have this checklist, is my asset in good condition? Let me run through my asset condition checklist and see yes or no, and it helps you to troubleshoot what are my weak links or my soil constraints that may be holding back my soil from really achieving that high self-organization and productivity, because plants and soils together can organize themselves and into a really high level of functioning equilibrium if we support them, and we support them with air and water. But there are times where they've lost all their carbon, or they're compacted and there's no air and water, where you have to kind of help them by doing some kind of intervention to get them on their way. And as long as you've got plant roots growing happily in there, or starting to grow happily, they'll do a lot of the heavy lifting for you of reorganizing your soil, building carbon back. Just look after the plants and they'll do a lot of the heavy lifting for you, as well as make you some money. So we've started to look at what you can do to take action to manage your soil health. So on that note, think about your other soil health aspects. Next week, we'll go into pH and the cations. So you're not allowed to drink any alcohol while watching next week, because you just won't follow. I'll have enough trouble talking about it, let alone you guys drinking alcohol. So make sure it's low strength beer or just lemonade for next week, because we're talking about cation exchange capacity and cation balances. So please just stick to the hot milk and honey, or a cup of tea. And that's what we'll be doing next week. So we're looking at a few of those other aspects that are on our soil health checklist. So thanks very much, everyone. And thanks, Catherine. I'll pass back over to you.